Hi, hello, vanakkam and namaste to all the learners assembled here at Learning Legacy. This is your companion Siddharth coming up with the start of the legacy that is to be continued in the form of quantum mechanics. Today, we will discuss about the Kirchoff's law and the Stefan Boltzmann's law that is taught to us today. So, let us look at the first formula we have arrived at. Rate of emission from any surface divided by rate of emission from a black body is equal to A of lambda. It means the amount of emission that any surface is able to provide in a given time, and the ratio of it to a black body emission is represented by A lambda. A lambda represents absorption coefficient from the material at that wavelength. You might think why emission and absorption has got together within themselves. If you think in black body radiation, we have studied that the amount of light which is absorbed is also emitted by the black body. So obviously absorption coefficient can be equated to the ratio of rate of emission from any surface by rate of emission from a black body. Okay, if it is clear, we will move on to Stefan Boltzmann law, in which we will also discuss Stefan Boltzmann's constant. So Stefan said that the energy that is produced is directly proportional to the temperature. So an equation was formed with the constant, as we all know. E is equal to sigma T per 4. The sigma represents the Stefan Boltzmann's constant, which is 0.56686 into 10 to the power minus 7 Weber per meter square Kelvin per 4. If E lambda is emissivity for that wavelength, E is equal to 0 to infinity E lambda d lambda. You can imagine this like a graph that is drawn to an infinite level. How will we find the area of a graph in max? We will find the differentiable part of it and integrate it towards the given limits. So here the limit is 0 to infinity, as we don't have an end for the emissivity from a black body or whatsoever the body which we take. So E lambda can also be written as T power 5, temperature power 5 into function of lambda T. Here you should notice the function is in small. It is not in capital F, it is small f. Why we are mentioning this small f, we will see in the next upcoming videos. I hope you all understood. Thank you. If you like the video, please like, share and subscribe. Learning Legacy. It is where you learn and create a legacy for your own life. Thank you.